Hey everybody, this is Alex Brissett from alexbrissettcoder.com, and we'll be talking about classes in Typescript. And pretty much if you're familiar with classes in JavaScript, you're familiar with classes in Typescript. But what's going to be the big difference? You can type things. But let's go over that. So we're going to start off a little bit unorthodox. Usually you do classes and then you discuss abstract classes. But I'm going to start with an abstract class. What does that mean? First, let's discuss what classes are. Classes are a way of defining a noun. This is the way I always like to think about it. So like in my in programming languages, you have verbs, which are like functions, okay? They do things. And you might have variables that are basically properties, or they're like adjectives. They're describing what is. So any noun, so let's say like an animal is made up of verbs that it does, functions, and it's made up of things that describe it, properties or variables. So what a class does, it helps you kind of encapsulate an idea. So let's say an animal, a person, a dog, or a cat, by encapsulate the different verbs or functions that it does and the different properties that describe it into one sort of abstraction. So that way it's much easier to be me thinking about a cat if there's like a cat that's described like a cat. But cats, let's say I'm going to be making cats, dogs, zebras, all these things, they're all animals. There's no thing that's an animal, right? They're like, we know that a human is an animal, a gorilla is an animal, but there is no standalone animal. Okay? It's more of like a parent idea, an abstract idea that we can think of animals through, or of dogs and cats through. So that's what an abstract class is. It's more like that higher level idea that sort of categorizes everything that's in common with a bunch of more concrete ideas. So we're going to create that abstract class. Abstract class animal. Okay, so we're saying, hey, we're going to create an abstract class called animal. Okay, and convention is to usually name it with a uppercase. So abstract class animal. And then you put two brackets. And then everything in the middle there is my description of my class animal. And everything we put inside of it, all the verbs, all the adjectives, all the functions are referred to as methods of that class, and all the variables are properties of the class, but they're both known as members of the class. Okay? Cool. So we're going to say that an animal typically has certain properties, right? So we're going to say it typically has a name. Okay? So we're going to say name, and then we're going to say names are generally a string. So we're going to declare that as a member. Now the question is, do you want in your code, do you want to let other code directly change the properties of your class? So like, can someone just go in there and just rename this dog? Or do they have to go through a special process to rename the dog? So if you don't care, and you just want to let anyone change it, I can say this is a public property. So this is called name, that's a string, which means it can be changed inside and outside of the class. Okay, but maybe name can change, because maybe a person might change their name whenever they want and they just change it. But maybe something like legs, okay, I'll make protected. There's protected and there's private. So we'll say legs is protected, and that's going to be a number. Everything has like a certain number of legs. Now, why would I make it protected? Because there's also private. The difference is protected allows any. So again, animal is going to be an abstract class, which means it's not a class. There's no animal. We're never going to create an animal, but we're going to create other classes from animal. So we'll create a dog class. We'll create a cat class. We'll create a person class, and those classes are going to inherit everything we defined in animal. So when I'm saying protected, I'm saying, hey, when we create the dog class can still change this legs property, even though it's defined in the animal class, but it still cannot be changed, altered outside of the classes. So it can be, so protected means it can be changed in the class and in any of its children classes. Private would just mean the only scope in which you can change this variable is within the class in which it's defined. So those are the sort of the three ways we can specify our different properties. Okay, so basically let's also add arms. So we'll add that as a protected legs no arms, which will also be a number. So those are 3 properties. And let's say we were to do a constructor. And what the constructor will do, now a constructor is a special function in a class. It's a function that gets called the minute you create a new instance of that class. Now again, this is an abstract class, so this constructor would be inherited to the child classes. But this constructor will run, and I can name parameters. So we'll say there's one parameter. It's going to be called name, which is going to be a string. Okay. And basically all this constructor is going to do, okay, is this dot name. Now this represents the instance of the class. Okay. Or this in JavaScript, which I'm assuming is going to extend the TypeScript, gets a little complicated. So in most programming languages, this always just refers to that class, or that instance of the class. In JavaScript, because of the way it implements classes, it can get a little funky. So if you've done React and had to bind your functions and your class functions, you probably are used to this. So what this is referring to is where this is invoked. Okay. So most of the time, that means it's going to be in the class because you're invoking it within your methods and whatnot. But let's say you're talking about a method of, or a function of the class that gets invoked, via an onClick event for some HTML element, then technically this becomes that HTML element. So this is why sometimes you have to bind this. Now, I'm not going to go too far down that rabbit hole today, but just kind of know that this in JavaScript and TypeScript is going to be different than this in C++ and C# and Java and other programming languages. But we're going to say this dot name equals the name parameter that gets passed in. We're going to say this dot legs is going to equal 0 because this is just an abstract type. This dot legs or this dot arms is going to equal 0. Okay. And then we're going to call a method saying sound. So we'll say sound is the function, and this takes just sort of a standard ES5 function. So basically it's going to look like this, and the sound is no parameters for the sound. Actually, yes. No parameters for the sound. Just deciding what I want to do, and it's just going to return, or actually it's going to console log a sound. Console.log sound, representing the creature making a sound. Cool. Okay, and then there's our class. There's our animal class. Okay, but I can't instantiate this animal class. I have to implement this animal class somewhere else. So let's create a dog. So I'll put a little line just kind of to make it clear that this class is created. And we're moving on to the a new class. We're going to now say create a normal class. So this is going to be a class dog, which extends animal. So basically what happens, what we're saying here, is that this is a new dog class, but we're going to use the animal class as its starting point. So it already has everything that's been baked into animal. So I don't have to redeclare arms, legs, and name. It's already assumed. Cool. But I don't want it to have 0 arms and 0 legs. That'd be a sad dog. Okay. No offense to any dogs that are tragically lacking arms and legs. But so what I'm going to do is I'm going to override the constructor. I'm going to create my own constructor for the dog class. Okay, and it's going to still take the name parameter because I still want us to define the name. Okay, I still want it to do the same thing that it does, or I can just really just redefine everything. You could just use super, and I could like do super name, and it'll literally just handle. It'll just do what the parent class does, but just to be a little bit more explicit. So basically what super is doing is that inside the new constructor for dog, we need to make sure that the animal constructor, because basically when dog runs, it's going to only invoke the dog constructor. And the animal constructor won't invoke per se. So what if I want it to? I want to make sure that the parent constructor happens. Okay, so in that case, when I say super, it's going to invoke the constructor of the parent, and that constructor needed a parameter called name. So I'm going to pass name from our constructor to that constructor. So essentially, it's just going to basically, instead of me having to redefine name, but again, I'm not happy with how many number of legs and arms, so I need to redefine legs and arms. So for a dog, I'm going to say this dot legs equals 4. I'm going to leave it at that. There's no arms for a dog. Okay. And it doesn't make sound. It's gonna bark. So I want to override that sound function. So I can just define sound myself. So then I just do sound. Okay, no parameters. Oh, I didn't mean to take a screenshot. Sound. And then I will just redefine it. So instead it's going to console.log bark. Okay, so in this case, since this is what's called overriding. So when you inherit from a parent class, if you rewrite the function name, this version of the function is going to run instead of the original sound from the parent class. Okay, it still technically has arms, or zero. The arms variable still exists, but it's still 0, and I don't plan on making any changes to it. Okay, in that case, we just hit save. Okay, and you know what? This is not returning anything, so I'm going to be explicit. I'm going to make sure that this says void, because when a function doesn't return anything, you're supposed to put void. That way, you make sure that it never does return anything. You know, that's what you don't expect it to return something. So to make sure that that's the case, I'm going to put that void as its return value. Okay, so now we should be able to create a dog. Okay, and let me see here. Oh, let's do one thing first. So we're going to say const Sparky. So Sparkies are going to be our new dog. Equals new dog. And we have to pass in, and again, the constructor is going to be invoked when we create that new dog. So we have to pass in the parameters, and it expects a string parameter. So for the name, so we're going to say Sparky. Cool, and we want to make sure that this dog is actually his name Sparky. So we're going to console.log the number of legs on Sparky's name. So Sparky dot name. That's how we access its properties. So if all goes well, we should get the name Sparky back on our console. If not, Typescript will tell us where we screwed up and we will fix it. So Typescript, tell us what's going on. And of course there is an error. So let's see here. Constructor name, parameter name implicitly has an any type. Name implicitly has an any type. Because why do we do here? Oh, because I passed a string there. So they want me to make sure that they're both going to be string. Let's see, was there any other errors? So let's see here. It had okay, constructor name, console is declared here. Declare variable console, that's somewhere else. Console.log, okay, I'm not quite sure. Cannot find console. Oh, okay, so we typed it wrong somewhere. Here we go, console. Okay. See, errors are useful. And that's it. Those are the two errors. Return, enable compile Typescript. Good, good. Okay, so that seems like should be the errors. Let's run it again. See if it comes up with any different errors. TS no practice. So I had to match up the typing. And there, yeah. See, console is the name Sparky. Okay, now let's try the console log the number of legs. Okay, that's a protected variable. So let's see if it lets us console log the number of legs. Console.log Sparky dot legs. Save. And it's running, it's running, it's running. Let's see what happens. And we get an error because that should be a protected variable. So property legs is protected and only accessible within the class. So then how would I know? Okay, Well, what we can do is we can create what's called a getter function. So the idea is when you have your protected and private classes, what if you want the user to be able to go look them up? But you want them to be able to look it up in a certain way or give certain information. You want them to go through a process. So maybe what I'll do is I'll make, you know, a function called leg check. Okay, leg check. Okay, and this will take no parameters. It's going to be just going to return no value. And all it's going to do is console.log this.leg. So this particular dog's legs. So we console that. And okay. And then what I want to do is we're going to replace this with Sparky dot leg check. So if I wanted to be able to change Sparky's legs, I would have to create a special function. And what if I don't want people to just change the number of Sparky's legs to anything? I only want them to be able to reduce, because you can't add legs to a dog. So you could create a special function that maybe, you know, you can only reduce the number of legs Sparky. You can call it like amputate or something. I know that's kind of dark, but you guys get the idea. The idea is you're trying to put constraints to mimic the behavior of the thing you're trying to model. Okay, Sparky dot leg check, and takes no parameters. So we just do that, and that should do what we want it to do. So let's save it. And then that's gonna run, and hopefully it should print out the number of legs. Yep, and there's the number of legs 4. So you have to create. So when you have protected and private members, you need those getter and setter functions to, or the other functions to be able to access those things, because it can only access it internally, which again gives you, the programmer who's programming this class for somebody else's use, more control over how it's finally going to get used. There's other cool advanced stuff you can do with classes. Like for example, I could define a function like a static. So for example, if I were to do, let's just do a weird example. I don't know why a dog would add, but we'll just do static add nums. Okay, and static add nums, and we're gonna have a and b parameter. I'm not gonna bother typing them, but I will say I wanted to return a number. We'll specify that. Okay, and then we'll just say return return a plus b. Okay, save, and okay. So now notice I'm not going to call this on Sparky. Sparky doesn't have an add nums function. Okay, when I say a static, what I'm saying is that I want dog, the concept of dog, to have this function. This may be useful if you want to create like a function to count all dogs that exist, that are currently in existence, or just to run some sort of function. Okay, like you might create like a math class, but you don't need multiple math classes, so you just might make it all its functions static. So you just constantly be like math.add, math.divide, that kind of thing. But here I can do dog dot add nums. So anything that's declared a static, you invoke it through the class, not through an instance of the class. I don't have to make an individual dog to use add nums. Actually, I couldn't. I can only use add nums via the dog class. So it would be 5, and I want to console log that, because otherwise we won't see the return value. Console.log parentheses save. So if this all works out well, we should see a number 10 at the end of our results. Okay. Oh, there's an error. Let's find out what it is. B. Parameter B is implicitly has an any type. Okay, so they're saying, hey, you want to return a number, and this is, you need to make sure that this is typed. So it wants us to type things. So if we're going to type the return value, we need to type the parameters. Okay, it doesn't like it when we don't type. So we'll do that. Number, because I'm assuming the way it's thinking is that it's possible by typing it any, by like not giving it a type, it is implicitly making it possible that something that's not a number be returned. So it wants to prevent us from making an error or having runtime errors as much as possible. That's the goal here, okay? That's the point of compiling, to prevent runtime errors and replace them with compile time errors, because the end user doesn't experience compile time errors. That's not their problem. And we're worried about the user experience. Okay? So let's compile that or let it run, and there you go. Add nums, 5 plus 5 is 10. So that's what you can do with classes. You can do a lot, classes become more useful once you have like sort of a concrete what you're trying to program. And you're trying to think through. It's a good way to kind of structure certain data and solutions and whatnot. And you can actually use, now that dogs are defined, I can actually use dogs as a type. So if I were to create a new function, so if I were to say like const myfunc, and that function does something with the dog, okay, I can actually now go, I want it to have a parameter named dog, that's a dog, okay? And now that Typescript will check to make sure that whatever we pass through as a parameter is a dog. Or I can say it returns a dog. So the function has to return a dog. So somewhere in the function, at the end, it has to return a variable that's the equivalent of a dog class. I can do that now. So you can create, so not only can interfaces help create sort of new types, but through classes you can create new types to even further improve your type checking and make your type checking even more specific to prevent errors. So my name is Alex Merced from alexmercedcoder.com. I'll talk to you guys later and see you guys in the next video.